All right, so what we're looking at today is patterns of deposition. All right, so when like a stream or a river is chugging along at a good pace, it's carrying a whole bunch of different sized particles. The faster it's going, the more particles it can, more different variety of particles it can carry. But eventually, the stream doesn't carry those particles forever. Eventually, there's going to be a spot where the particles get deposited by whatever carrying them. Now, what we know from previous lessons is that different particles settle differently. That bigger particles settle faster typically than smaller particles. Flatter particles settle more slowly than round particles. More dense settles faster than less dense. So like when the river or stream or whatever is carrying all these different particles, when it comes time to deposit them, some particles are going to deposit first, some particles are going to deposit last. And that results in sorting of the particles. And that's what we're looking at today. All right. So the first type of sorting we're going to look at is what we call vertical sorting or graded bedding. And it kind of looks like this here, where you have particles where on the bottom you'd have the particles that settle the fastest. So typically the big round, more dense. And then as you work towards the top, you have particles that settle more slowly, so the flatter, smaller, and less dense particles. All right. Now, where you can get this taking place is if you have a stream going really, really fast, and then it basically just stops. All right. The particles will kind of settle out like this. All right. And I could demonstrate that with this little device right here. All right. So what this has is a bunch of different sized particles in it. And by me shaking this thing, it's kind of simulating what's going on with a fast moving stream. It's carrying a bunch of different sized particles. But then all of a sudden, if it just all of a sudden stop and let it settle out, let's try this again. All right, what you will notice is that the bigger particles are right there, the pebbles are right there, and then right there I have the sand, and then the smallest particles up here haven't even settled yet, but pebbles, sand, and then the silt and clay type stuff up here. So it's changing, it's being sorted from biggest to smallest as they go up. All right, so that's an example of vertical sorting. Now, if you're analyzing sediments, if you're studying sediments, sometimes each one of these is called a graded bed. Sometimes you might see a whole series of these things. Right? Now, what that indicates, well, to get the graded bedding initially, you have to have a stream or something that's going pretty fast. And the reason being is you have a variety of particles there, and to have a wide variety of particles, the stream has to be going pretty fast, because if it was going slow, then I'd only have the smaller particles. So you have to have a stream that's going pretty fast. So what this would indicate, that would be basically like 3 different occasions where that stream or that river was going pretty fast. So seasonal discharge variations in the stream can lead to a series of graded beds. So each of these would represent a period where there was a lot of water flowing through the stream, and then in between where there's really just the small stuff, that would be like when there wasn't very much water going through the stream. All right? So you get a series of graded beds like that. Now, another place where you can get vertical sorting is with something called a turbidity current. And what a turbidity current basically is an underwater landslide. So let's say that I had land, there's the ocean, and here's the land like that. And maybe there's an earthquake or something, and it triggered a bunch of this material right here, start sliding down the side of the hill there, underwater hill. What would happen is it'd kick up a whole bunch of particles right there. Right? So basically like a cloud of particles, a bunch of different size stuff mixed together. And when those particles settle, it's going to settle the biggest ones on the bottom and then the smaller ones on top. So when that cloud of sediment that gets kicked up from the landfill or landslide settles, it's basically just like me with that little shaker device I just showed you. The big ones go on the bottom, small ones go on top. All right, now to better give you an idea of what a turbidity current looks like, got a little short video, a little short YouTube video, just to kind of give you an idea what it will look like. So there's like the underwater landslide, like a big cloud of material moving downhill. Gravity's pulling it downhill, making it go. But eventually, when all that material settles out, it's going to be the big particles settling on the bottom, the small particles on top. I feel like I should be running away from it. Anyways, it's just a bunch of, it's showing the same thing from a bunch of different angles, but it gives you a rough idea what a turbidity current looks like. This is in the lab, but it's basically like that in nature too. Kind of cool looking. All right. Now, actually, this vertical sorting right here is not that common. Because again, typically you have to have a stream that's going really fast and then basically stops. Usually what happens when a stream enters into a larger body of water is it slows down gradually. And that still results in a type of sorting, but it's not going to be sorted from top to bottom. So let's say I have a stream that's chugging along at a good pace and it starts to go into a larger body of water. Typically the mouth of the stream will get wider. They'll cause it to slow down. And if it's going really fast and it's carrying a bunch of different sized particles, the biggest particle will be carrying will be these boulders and the cobbles. So as it's slowing down, it's the boulders and then the cobbles get deposited. It slows down some more and then the pebbles get deposited. Slows down some more than the sand gets deposited, slows down some more than the silt gets deposited, slows down some more than the clay gets deposited. So you'll notice that the big particles are near shore, and the farther you go out in the ocean or the farther you go out in the lake, the particles get smaller and smaller and smaller. So instead of like going from big to small, from bottom to top, it's going from big to small, from near shore farther out. If you've ever been in like a kayak or something to where in a lake where a stream enters into a lake, a lot of times what you'll see, that spot where the stream enters in the lake, you'll see a whole bunch of cobbles right there. But if you paddle out, 100 feet offshore, you don't see the cobbles like, 100 feet offshore, a couple hundred feet offshore. It'll be more like pebbles and stuff like that. All the big rocks are going to be right near the shore because they settle out pretty easily. All right. So this is a much more common type of sorting than you have up here. All right. Next, glacial deposits. All right. Well, glaciers are really big, and glacier is made out of ice, which is a solid. So glaciers can carry any size particle. It can carry little grains of sand. It can carry big giant boulders. As a result, it has tremendous amount of force moving all this stuff. We said before that glaciers frequently leave scratches on rock. But when it comes time to deposit this stuff, as a glacier melts, what usually happens when the glacier melts, all this junk the glacier's carrying just gets dumped there, all right? So the particles it's carrying are all different sizes, and this material it's carrying, when it just gets dumped there, those particles are all unsorted. It's just a mixture of all stuff all mixed together. So if you could say like the pattern you get with glacial deposits is there is no pattern. All right, so it's a bunch of different size and shape things all mixed together. Right. So there's a few exceptions to that, but generally speaking, glacier deposits are usually unsorted. Now, again, because glaciers are really strong, powerful things and ice is a solid, it can carry really, really, really big particles, big giant boulders. And when the glaciers melt away, a lot of times they just leave these big giant boulders seemingly randomly in areas. So if you live in an area that was covered by glaciers, a lot of times you might be walking in the woods or something and you just stumble upon this just big giant random boulder. Doesn't seem like there's any reason why it's there. That's probably what's called an erratic. Right? So an erratic is a very large glacial deposit, like a big giant boulder type thing. So there was an article in National Geographic a few years ago about erratics, and it's kind of give you a little glimpse of some of the pictures from that article. So it was this episode of National Geographic. So here's a picture of Central Park in New York City. And in Central Park, you can find some of these big giant boulders there. They happen there naturally. The glaciers dumped them there. And you can see this kid's trying to climb up that boulder, so it gives you an idea. You know, the boulder starts down there, so it's probably twice as tall as that kid is. So that boulder is probably, 8 to 10 feet high. So that's a really big boulder right there. Another picture from the article on erratics. You got this one right here. So again, just to give you an idea of the size of these things sometimes. Here's a parking lot. Here's the erratic, the big boulder left by the glacier, and there's a car right there. So it's easily at least twice as big as the car, maybe 3 or 4 times as big as a car. So there's the erratic, there's a car. Now this one right here is kind of interesting. Here's the big erratic, and then it looks like it's sitting on a little pedestal right there. Somebody didn't place it on there. That's the way nature made it. So the reason why it's like that is the ground used to be up here, but the soil over here and over here washed away. But the weight of the boulders pressing on that spot right there, which kind of like squeezed that soil closer together, which made it like harder right there. So that's why that part is still surviving. It looks like it's on a pedestal. And if you're thinking, hey, wouldn't that look like it'd be cool just to knock that over? There is a barbed wire fence around that rock, so people don't do that. So here, this is a modern day glacier. And what you can notice here, this is like a glacier someplace up north. But here's a big boulder that's kind of sitting on the ice. So as soon as all this ice melts, that boulder will end up being an erratic. And last one we'll show you here is a picture of one in Rock Haven, New Jersey. There's a big giant erratic. You can compare it to the size of the house over here. So you compare that, you know, that erratic's probably at least 15 feet high. And that's what they named the town Rock Haven. They named it after that rock right there. And also the road goes around the rock. So I'm curious how many times someone crashed into that. The battle between that rock and the car's not going to win. But anyways, those are glacial erratics. All right, next up, wind deposits. Wind deposits. Right. All right, with wind deposits, air acts a lot like water does. Some of the features you get with wind deposits are similar to what you get with water. So just for example, when we drop the particles in a tube full of water, we saw that the round ones settle faster than the flat ones settle slower. All right, that's what happens when you drop different shaped particles in water. Well, I could do the same thing with air. I got these two pieces of paper right here. One I'm going to leave flat, and the other one I'll wad up into a ball. So they're both the same size and type of paper. So they both have the same size and they both have the same density because it's the same type of paper. But if I take them and release them, you can see the round one fell a lot faster than the flat one does, just like it would if I dropped them in water. All right, so a lot of the characteristics of wind deposits are similar to water. It's just that air is like thinner and not as powerful as water is. So the features are going to be with much, much smaller particles. Where here you might have particles that are, you know, boulders, cobbles, pebbles, sand. You can get vertical sorting in air too, but maybe the biggest particle in the bottom would be the sand, and then it'd be like silt and the clay and so forth. So it'd be much smaller particles. So similar to water, but smaller particles. Now, one feature that is more common with wind deposit, though, is something called cross-bedding. And cross-bedding kind of looks like that. And cross-bedding is generally caused by a change in direction of the thing doing the depositing. So on one occasion, the thing doing the depositing might cause sediments to get deposited like that. If the thing doing the depositing changes direction, well, then maybe it deposits stuff like that. If it changes direction again, maybe it deposits things like that. So you end up with these layers that kind of cross each other. That's what cross bedding is. Now, it's most common with wind because it's easiest for wind to change directions. You can get it sometimes in streams because stream channels can change directions with erosion and stuff like that. But it's a more common feature to find with the wind deposits. So cross bedding you generally associate with wind deposits. And lastly, sand dunes. Another feature that's commonly associated with wind deposits. With the sand dune, the typical shape a sand dune has is that right there. And the significance of the shape is that the flatter side is the side that the wind's coming from. So the flatter side here, that is the windward side of a sand dune. And then the steeper side is the leeward side of a sand dune. So if I saw a picture of a sand dune and sand dune looks something like that, right off the bat I'd know what direction the wind's coming from because the wind always comes from the flatter side. So that means the wind's flowing like that over the sand. All right. All right, so those are the type of deposits you get with wind, glaciers, and some of what you get with water as well. All right.